Okay. Good afternoon to anyone. Okay, I am Dominique Legrand, President from A2V, National Association for CCTV. And I'm very glad to introduce those four experts for this subject, perimeter protection of critical sites, or way and means to cross a barrier. So just for the beginning, just a few words about N2V. You will have the slides on the website, so you will be able to read this later. So I need my glasses. So you've got four thematics meetings per year, roughly 200 person on each meetings. We've got huge events. In 15 days, we've got the university safety universities of safety N2V, video days at the end of the year, and the night of N2V in 1 year. We've got working groups. We've got remote meetings and a training center with 14 thematics. And we've got the Pixel guide, which is state-of-the-art for roughly 400 pages with all our members. Here we are with 155 members. So they made the state-of-the-art for us for all the thematics of safety and security questions. So if you want to scan the QR code, here is the next universities in Lyon. 2 plenary sessions, 12 workshops, 15 exhibitors, and 800 Congress participants. So I've got a present for you, just for the very beginning of the session. Since 20 years, we've made 3 tools, and those tools are here. First of all, for all the subjects that we'll see together this afternoon, we've got always, for all thematic problem, 6 blocks to answer. A strategy question, first of all, and then organization, and then technical problem, then cost, then legal, then ethics. And I mean, you need to have a very good sight of all those 6 questions to be able to say my project is good. And this is the angle for my guest to answer to the problem of perimeters questions. If you want to have just a few words on the strategy problems, you always have, this is our second tool, you always have a before, a during, and an after. Because before is to prevent, during is to protect, and after is to solve. And actually, we can say perhaps it is 3 separate solutions. To try to make all in one is not obligatory a good vision. So you've got before, to prevent. How can you make the prevention for perimeters problem? Of course, during is a very important questions, but you have to answer those questions in seconds or in minutes. And after, it is too late, but you have to solve what had happened, but it is too late according to me. So N2V is always focused on these during questions, and if we focus on this during question, we have what we call the 1, 2, 3, 4. One, first is to detect. Secondly, you have to transmit the information that something is abnormal. Then 3, you have to understand what happened. And then 4, you have to you have to go to the problem for the action, the police and so on. So think about this third tool, 1, 2, 3, 4, because the weakest, le chaînon faible, the weakest what? The weakest point. The weakest point of this 1, 2, 3, 4 is the reality, in fact, for your project. So you have to be good in all those 4 steps. Okay, so here is the workshop topic. And I'm very glad to introduce those 4 experts. And immediately we can begin with Alexis. Alexis, it is to you. So I have to switch this presentation. Alexis is here. Ah. Aïe. Comment on fait? Oui, là. Okay. You've got 10 minutes.
Thank you. Thank you for your presence attending today this round table. So what I would like to discuss today is fiber optic. Fiber optic can be in any type of cable. Submarine cable can be also deployed anywhere in the world. So subsea, it can be also under the road, along the railways for data communication. So if you know, in railways, for example, just if you take the railway network in France, I don't know if you know how many kilometers of fiber optic is already deployed. It's 26,000 of kilometers. Can you imagine? It's huge. So the particularity is that knowing that you use this fiber just for telecommunication purpose, just to transfer data. That is the only objective and purpose of the fiber optic deployed already along the railways today in France and across the globe. What I want to discuss today is what if we connect the interrogator, for example, that Fosina is doing to this cable. Basically what we do is that we convert all this fiber optic network into a sensor, into a distributed sensor for temperature monitoring, strain monitoring, and acoustic monitoring. So I will try to explain a bit more how does it work, because it sounds a bit magic when we talk about it. So basically you connect a box, an optical box at the end of the fiber. Then the fiber can be tens of kilometers, hundreds of kilometers, thousands of kilometers. And it can be deployed buried, so invisible. No one can see it, or on a fence, or on the seabed. And the idea is that we send a pulse of light down this fiber. As soon as someone is walking along the fiber, or driving a car, or digging a hole, what will happen is that an acoustic energy will transfer basically below the ground, and the fiber, at a very microscopic level, even nano, will basically extend and compress. So the light basically that is transmitted from our interrogator, a portion of this light will come back. And that's what we call a backscatter light. Knowing the speed of the light in the fiber, you know also the time that it takes for the backscatter signal to come back. So you know exactly where happens the event. And I just demonstrated why we call it a distributed sensor. It means that over tens of kilometers, you can have thousands of events happening simultaneously. We'll see thousands of events. So having said that now, you have a network. Let's not forget that, because it's already under the ground, even here, across cities. That's what we call smart cities and so on. So you have a network of fiber, and as soon as we connect to it, so then we can track in real time, the location of a train, the speed of the train, and if, for example, the train has a flat wheel. You can monitor the traffic for cars or also the marine traffic. And I will show you that in the next slide. We have some data where you can monitor boats, for example. Boats means also submarines, for example, and so on. So it's very important to know that the fiber is the sensor. So it's completely passive, no need of electronic. So we will talk, I think, about CCTV. It's complementary. So here you just have the fiber. It's buried. It's covering real-time 24/7 a day the entire length of the asset. And you can raise an alarm from it and then trigger some other sensors like CCTV, like drones, and so on. So from that, you can monitor individuals, you can monitor working crews, cable theft. I think you've heard about this sabotage that happened recently in France regarding someone basically cutting the fiber network. So this can be monitored in live. So how does it work? It's not only sensing, it's also machine learning. So a lot of people are talking about machine learning, intelligence, artificial intelligence, and so on. That's really something that is completely on purpose for this type of technology. Why? Because we don't only detect events, but we classify them. So it means that we can distinguish someone who is walking from someone who is digging a hole from someone who is driving a car. And this is very important because then, for example, in some countries, we've been asked, can you monitor an elephant? Because I need to distinguish, for example, if an intrusion is from an elephant passing a fence, for example, over a railway, or if it's a human, because the intervention will be completely different. So like that, I would say no. I need an elephant basically walking along the fiber so that our interrogator and the machine learning algorithm will learn from it. As soon as we learn from it and we understand what is the signature, the acoustic signature of an elephant, then that will be classified as an event, and in the future we'll be able to detect them. So for the client, basically the idea is not to see in live the data over depth and time, but it's to see on a GIS map all the asset with all the fiber layout, and in live to raise some alarms saying, okay, this is an alarm identifying basically someone walking. So this is a type of example where we deployed a fiber. We didn't deploy the fiber. That's very important. The fiber is already existing subsea. We decided to connect to a fiber which is going to an offshore wind farm. And we said, okay, the client said, what do we monitor? Can we monitor the fatigue on the cable? Can we monitor, for example, a boat which is approaching and which is trying to deploy an anchor, and the anchor will damage the cable? So it's like perimeter intrusion for a port, a harbor, and so on. So what you can see here, the top section is basically under a road, and every line that you can see here is a car. So from that, you can identify every car that is on the road. From the slope, you can deduce basically what is the speed of the car, and if there is any traffic, any accident, and so on. Below, it's the section which is going subsea, and you can clearly identify basically a Zodiac, so a very small boat that was doing returns. And this is showing you the sensitivity of this type of technology, knowing that the cable was 50 meters below the boat, so on the seabed. So your asset basically, and this is I think the goal of this roundtable, is to see what type of technology we can deploy for this perimeter intrusion. And you can see that fiber optic can be one example of technology that can be complementary with others to basically monitor very different type of intrusion without knowing that there is someone who is monitoring, because it can be buried.
Thank you very much. Yes, you can applaud him. Thank you very much. So, Virgile, we continue for the second demonstration. Okay. You've got 10 minutes.
Hello, my name is Virgile Auger. we talk about perimeter protection. Why creating perimeter protection? And my main purpose will be how to pass by perimeter protection. So the first question is, why putting perimeter protection? To prevent intrusion, to delay intrusion, to signify a property line, to deter, but it depends of how it looks like. And sometimes you have to put a perimeter protection because you have some legal obligations. This is the main reason why you are enclosing a place. This is the main reason why you need to be very efficient on your protection. This is your goals. And the goals of the so-called bad guys, it's to pass by what you've done. And we'll see that it is a child's play, a child's game. One of my ex-jobs was to try to pass by all the places I have to study. My ex-job was trying to find the weakness point, was to find how to do, how they will do, and finally how we can manage to do it the longer as it's possible. Because when it's long, we are able to detect the action. And the main goal is I'm putting perimeter protection because I want to fix something, I want to block something. The other guy wants to pass by, and my real job is to do it the longer as possible because I'm always binoming protection and detection. And this is the main goal of my 10 minutes. I put that pictures because for me it's the best ideas, the best picture to explain what it is to pass by a perimeter protection. If you know how easy it is, when you want to do it, when you have a goal, a very precise goal, you always find a solution to pass by. And there is always a solution to pass by a perimeter protection. Always. Our job is not to do it perfectly because it's never perfect. Our job is to do it the more longer as it's possible. I'm repeating it because we are always making a mistake. The mistake is to think I put a perimeter protection so I'm safe. It is not a good idea to think like that because it's wrong. And the bad guys will always find the solution, and you, as a good guy, you think you are safe, so you put your guards slow and down, and then they pass. So it is a child play to pass by. Why? Because I said they always find a solution, because when the goal is important, even if it's a big place to pass by, they will find the solution. Here I'm putting the picture of a climbing man. I don't want to be at his place, and he's doing it very well, and he passes. So when they want to pass by, they do, and they do it for them very easily. So that first picture is to explain that you are not able to do what they do. You won't think as they will think, and they will manage to pass. And you think you are safe, and you're wrong. So the first picture is about that. The second picture is you put rules, you put techniques, you put some elements, thinking that, okay, it's safe, my perimeter is closed. And then we call it the user experience, UX, and they show you that you think you were safe and you are not. This picture, I'm not sure you see it very well, but it is a barrier close to a road. Normally, they will stop, and the user experience is they pass by the road by the sides. It's a very important picture because you have the technique, you have the rule, you have your goal. I have a road to block. I'm putting a technical material, a barrier, and then they pass anyway. And this is a real good simplification of real life. When they want to pass, they pass, and sometimes it's so easily to do it. Third picture is the weakness point. You put a real big chain, it's okay. From a director of security point of view, you've done the job, and then it's off. And whatever the reason, your chain has to be repaired, and the guy who repaired the chain do it his own way. So I'm not sure you see it, but there is a little plastic chain putting together the wall blocks. And if you not look at your defense system, you have a weak point and you do not think it. So all the time when you put technical things, you have to all the time check it. I will be back on that. Other point, I should put bigger picture, but it's a place when you can climb and you have a camera and they put some paint on the camera, and the picture is for that. It's so easy to do, in fact. It's so easy to do. If you used to climb sometime for doing sport or things like that, you always find the solution to get out, to get in, to do what you want. So when you are a security director, you have to think that it is very easy to do, very easy. Other point, we call it the climbing points. You won't think, because you do not think like that, of the obvious point. The obvious point is how the guy will do, and he will see things that you won't see, because he has the way to think like that. As you see on the picture, you have a railing, you have a fence, and that fence has a block where I can put my foot, and then I pass off. And sometimes it's just because it's so easy, because you put your very good fence, you are okay, but you have neighbor doing kind of the same thing, but the junction between your own fence and the fence of your neighbor, creating a weakness point. It's the junction between the two fences you can pass by. Why it's so easy? And another picture, it's a stick for electrical things, and maybe you can see as a ladder. And sometimes it's so easy because you do not choose the good product. Here, it is a door, it is a kind of portal, but in fact it's a ladder. And you can climb it very easily, and you can come in the very safety place very easily. And sometimes you have also the human factor. You have everything. You have the rule, you have the technology, you have the safety, but the human factor doing as he has to do, and do not respect anything. So what you have to do? You have to think it's possible anyway to pass in. So all the time you think it's possible. Then you have to think your defense in a depth. We call it défense en profondeur. You have to call it as a very long-term strategy. Yes, and then you have to combine physical difficulties and the ability to detect. Very important to combine. Then work on the time to pass and the time to detection. I have to finish. The time of intrusion must be longer than the time of detection and reaction. And then all the time, you have to repeat it again. Natural solutions, you can use natural things. I used to do it, it's my specialty. It's not perfect, but you can do very, very good things with natural products. And you just have to think how to image it, and it's good for the image of the site or the place, and it's good also because you can work on the on the vegetation with the detection. Thank you. It's very...
Thank you very much, Virgil. Okay, thank you for that. Just a minute for the next one. Philippe now will explain to us the next vision of this problem. Okay, Philippe, you've got 10 minutes.
Thanks. Hi, everybody. I'm Philippe Leclerc. I'm working in a safe cluster. Cluster is not a good word. Good word after the COVID-19. I will explain you quickly what is a competitiveness cluster. Well, kind of tool, state tool to make SMEs, starts up, big group, big companies, academics, universities working together. It would be like creating mini Silicon Valleys. And for safe cluster, the topics are from the space and helicopters, drones, airships, to defense, security, safety, and smart cities as well. I'm personally in charge of securing big events and the protection of sensitive places. So we are located in the south of France, in Aix-en-Provence. We've got some places all around France, and we gather more or less 470 companies, all types, and they have to be members. So we give them the opportunity to work together. This is important because sometimes when you are a small company, SME, you need to know your counterparts. You need to find solutions, especially with the academics, with artificial intelligence, with cybersecurity. So we make it's like a melting pot where people can work together and find some complementaries. And we help them to find some issues with Europe, also some other countries, by funding them funds. So let's talk about the main subject. I won't list because this has been done very properly and nicely before. And what I think now is the threat, the actual threat. So maybe first for me, so I have to explain just before I was in charge of sensitive places for the Ministry of Defense. And sooner I was in charge of, I was the director of security of the Palais des Festivals in Cannes. So I have to face with some of those threats and actual threats. So now, when we can see on the Eurosatory, drones and robotics can be threats and can jump easily fences, every kind of fences. So we have to deal with the third dimension. Another threats come from groups. The activists, of course, terrorists and hooligans, for the football fans. You could see just recently what happened around the Stade de France. And those groups, activists, they are more and more present all around our sites, and they act with new methods, like gluing themselves on the ground, on windows, chain themselves on fences. So those things we have to think about it as well. They're not really, sometimes they don't really jump, but they can prevent people from entering your site. And the last is the lone wolf, the guy that could enter your place, not jumping anything, but sometimes by the main door. So some point of view from my experience, the physical protection can have some different things, including the fiber detection on the ground, on the air, has to go with an efficient and deterring control access system. So if first people realize that you got very good access control, they can imagine behind there is an organization and some people who could react very quickly. So this is really deterring and efficient, of course. Of course, the physical protection has to go with good procedures, because, of course, there is no perfect system, so you will always have to deal with intrusions. Then you have to deal with very good procedures to react quickly. You talk about that. You have to react. This is very important. And of course, you have to deal with the police, with the forces, and you have to have very good cooperation with the people in charge of national protection. This is really important to have this everyday communication with those people, and they can make some tests to see the level, to check the level of your protection. So what is the future from my point of view? Of course, we can talk about this for hours, but I only got a few minutes for that. From what we see in our cluster, because we gather, and cluster is made to deal with innovation. So we see day after day the innovation, French innovation, but sometimes international innovation. Those protection goes, and especially the video goes with the development of artificial intelligence to make the false alarm and anomaly detection the lowest as possible. So this is the future of protection of our sites. Second is the incoming of robots in our everyday life, and we're going to use those robots more and more often, and this will create maybe some new jobs. Today we've got some agents in charge of security, human security, sometimes with dogs. Maybe tomorrow the dogs will be robots. And third, especially in France, in Europe, let's say in Europe, we have to deal with the legal procedures. One of my job in Safe Cluster is to mount experiments in real conditions, especially in the purpose of the Olympics. So we put some technology in stadiums and so on with real people, public, fans, and we check if the society accepts those technologies, if the operator accepts this new technology, if the security agents deal with the new technology, and if those new technology cope with the GDPR and the regulations, the French regulations. And sometimes I have to admit that in France, our glass limitation is the law regulations. We can do many things with the video and so on, but we are dealing in a universe made of rules, and we try as well to push a little bit those walls and to develop and to improve innovation. Thanks for your attention.
Thank you very much, Philippe. And then at last, we've got Alexandre. And then after we will be able to take a few questions.
Hello. Sorry, I have some problem with my presentation. My name is Alexandre Prunier from BSA, and I will present you the working group that the name is Infrastructure and Critical Site. Thank you. So the Cluster Eden is a French security cluster. Eden means European Defense Economic and Network. Oh, sorry. And yes, okay, sorry, a slide is missing. And so it's a civilian security network for small and medium company, up from 1 to 50 employees. It was created in 2008 and to provide networking between institutions and innovative companies. Eden represents a unique point of contact for national and international institutions, and they make a great job for us. They organize events where we can provide and propose and present our solution and innovation. Second, the Eden cluster, like Safe Cluster, I think, is composed of different working groups, and including working group of infrastructure that I will discuss after. And but we have also other working group like in cyber or for NRBC threat. The objective of the working group is to propose a global offer for our customer and to improve our product. Another objective of the working group is to get involved in standard on the regulation. And for example, our working group in infrastructure is involved in blast test certification for European test. We don't protect fixed installation than moving installation, and the protective design related to critical sites needs to a large scope of expertises, as there are many actors in the construction processes. You have architect, engineer, IT engineer, optical fiber engineer, and builder. So it means a minimum methodology. As I was saying, we design infrastructure such as military base, technical site, and administration site. And one of the particularities is that that we have to be able to protect different kind of site, of places, and we have to protect this site from different kind of operating mode. So I will show you something. It's not mathematics, it's just a schematic figure that shows the evolution of the cost of the security function of the standoff. So we know that the best solution, I think you will agree with me, the best solution is to have a minimum standoff between the potential site of explosion, for example, and the asset that you would like to protect. On the green line, we can see the price of the cost of land and the perimeter protection. On the orange line, you can see the cost of the hardening, and the purple line is the total cost of the protection for your site. So our job in the working group is to to find a fair price for the protection. Then our working group is composed of companies organized by specialty. We have passive protection. That means non-operable system like civil engineering construction, optical fiber network, or fixed barrier. And you have active protection. That's mean operable system security like CCTV, control access, and you can have detection intrusion and infrared detector. So I will speak after about the different innovation that we complete, and I will pass the next slide. I would like to say that one thing that is very important for us, that the success of a security design project could be based on the quality of the project management. You have the expertise on the project management. So the working group at Eden encourage the exchange of ideas, innovation, and feedback, return of experience. And I can say that there is a very nice collaboration between member and actor, thanks to Eden, Charlotte, thank you. And so there is no feeling of competition. Competition is not possible with our functionment. So, yes, of course, we are your people, if you are interested. And so we have developed a common strategy for protecting site. And so one thing is very important for us is when we build in a sensitive area or in poor countries, you know that another important point is the local perception of the local population of what we build. Because for us, we know that if your construction is too aggressive or too flashy, the local people could disagree on what you do, and it could be a new risk for the project. So I will speak about now the risk analysis. 2 minutes. Okay, sorry. Okay, I will be faster. So the quality of a security design depends too of the well understanding of the client customer requirement, and one of the requirement is the risk analysis. This video is an example of a risk analysis based on operating mode. At the working group in Cluster Eden, we have a unique space where we can mix different profiles, so that's very interesting. And we can have the perception of specialists. So I will be fast. We define the level of threat. In our methodology, we have the level of threat and the level of protection. And so we have our risk analysis, and we can include standards like STANAG or IG-300. And so we consolidate this risk analysis in order to reach the design criteria of the customer. So each of our solutions have been classified in level of protection, so we can know what we do, we can know what we can't do, so we can improve our products by innovation. Here I will present you like a synthesis of what we do. I like this picture because it's a military site and it's actual. So we are in capacity to define the level of threat for each of this operating mode that you can see at up of the slide. So we have impact, for example, explosion. We have electromagnetic with SIPL. We have fiber, cyber, espionage, and other scenario that could be imagined. And we can provide all type of solution for this site. I will pass. I won't present this presentation, but I will discuss after if you are interested. And I will present now first example of simulation of innovation that we are very, very proud of it. Blast solution developed with Lafarge company. The Ductal Blast Plus is a formulation that is designed against blast and impact effect. We have innovated in this material by testing, experimental testing, with small explosive charge up to very big explosive charge, as you can see on the right of the screen. And we have CAST, the largest anti-blast lab in Paris, in a European agency. And Titan Prefa, who is here, is in capacity to mold our solution in his factory. The second and the last innovation is Focina. He presented his company before, and they develop a very specific solution for detection intrusion, and they are able to detect an intrusion up to 200 kilometers, and so they develop software, and this solution is compatible with Ifotech, who built a transcoder, so they can adapt their solution on existing site, and it's very interesting for our retrofit. Thank you.
Thank you very much, Alexandre. Okay, so we've got a few minutes to continue with perhaps a few questions. Have you got any questions? If you haven't, I can begin. I'd like to ask you for all both. First, I forgot that Eden is an all 6. Safe cluster is over there. A2V is just near here. And Focina, Eurosatory lab in all 5A. Okay, so you can continue to discuss with them just after. So I've got a short question, short answers. What do you think we will be able to do in 2 years, 5 years, or 10 years? I mean, short term, what do we need to have to deploy something to control the perimeter of a factory or something very hard to protect? So in 2 years, what we do have to deploy? 5 years is a midterm. It is not ready. You are working on it, but it will be ready in a few years. And in 10 years, what we expect to do in 10 years? Short answer. Can I have another microphone? Okay. Who wants to begin? 2 years, 5 years, 10 years. It is always my question.
I'm the first in a row. So
okay, go on. Go on, Walter.
In 2 years, maybe development of artificial intelligence, as I said, that
yes.
will go very quickly to get
it already
the
works.
security to be more efficient, to get the false alarm off and things like that.
Mm-hmm.
5 years, the same. It's the evolution of the regulations.
Yes.
So I think if we can explain what the technology will give to the population, that it will give more security and not get into their private life, so the law will evolve in a way that we can do more things to protect. And in 10 years, who knows?
Who knows? But
I
say
don't know. Maybe
it
robots will do it by themselves.
It is recorded.
Yeah, and I cannot.
I
10
cannot.
years
You don't want to say. Okay. Have you got an idea for 2 years, 5 years, 10 years?
Yeah, I think 2 years is a good point. I mean, improving the false alarms between the complementarity between the technologies, the sensors, and so on. 5 years, I would say, cyber security. So it means that how can we ensure that someone will not try to come into these sensors and try to revert basically the original purpose, which is perimeter intrusion. And 10 years, I would say that the complementarity between, because you will have perimeter intrusion, you know, between countries, between cities, and so on. How can we leverage that? So how can we, between cities, between different agencies and so on, how can we leverage and learn? Because that's what we had as an issue in the oil and gas market, is that what do? We can leverage much more the application with data. And gathering data from a lot of different institutions, different agencies and so on can be very useful. And maybe in 10 years, with a lot of data gathered by different countries, cities, and so on, we can do a lot more.
Okay, thank you.
My answer will be oriented because I'm an engineer and a designer of the security. So for me, what is very important tomorrow, so in 2 years, is to allow us to security manager to have a global approach of the risk. For me, it's very important because you can have a very big anti-worm barrier, but if your cybersecurity this system is not hasn't a sufficient high level of protection, you will be vulnerable. So for me, it's to train people to have a global approach. And in 5 years, I think that drone will be a great vector for different kind of threat, like for explosive to transmit some object in jail or something like that. And for 10 years, I think we have to watch a lot of movie in science fiction to imagine a new scenario.
Okay, thank you. And Virgile?
I may say for 2 years and 5 years, the total deployment of technologies, artificial intelligence, creation of data, and cybersecurity. The real incoming of cybersecurity in the field of safety. And for the 10 years, I may say the return of the off-the-grids system, the rustic things, the simple things, and the real wedding between the full technology and the off-the-grid systems.
Okay, thank you. Okay, we have to stop. So we can continue to discuss just here into the Safe Cluster, Eden, Eurosatory Lab. Thank you very much. Thank you for you all, and see you tomorrow at the same time, same hour to continue with another subject. Thank you very much.